Core components of humanoid robots. Reducers. Just like the flexibility of the human body depends on joints, for a humanoid robot to perform all those movements, it all comes down to the reducer. First, what is a reducer? Simply put, it is the gearbox inside the robot's body. Just like a car needs a low gear when climbing a slope to gain more power, a reducer converts the fast, weak rotation of the motor in the robot's joint into slow, powerful rotation. This allows the robot to work with strength. Besides, the motor spins too fast. Without speed reduction, precise motion control is very difficult. Reducing the speed also increases torque and boosts power. With the help of reducers, robots can perform various movements in a stable and smooth way. Currently, there are three main types of reducers for humanoid robots: planetary reducers, harmonic reducers, and RV reducers. The first type, planetary reducer, it consists of a sun gear, planet gears, and a ring gear. It reduces speed through planetary gear transmission. Advantages: compact structure, high transmission efficiency, strong load capacity, low cost. Disadvantages: low single-stage transmission ratio, average transmission precision, not as good as harmonic reducers. The second type, harmonic reducer, it is composed of three main parts: wave generator, flex spline, and circular spline. It transmits motion and force through the elastic deformation of the flex spline. Advantages: high transmission precision, large transmission ratio, small size, and lightweight. Disadvantages: since the flex spline deforms repeatedly to transmit torque, it has extremely high requirements for material fatigue, strength, purity, and consistency, resulting in complex manufacturing processes. The third type, RV reducer, it is a two-stage structure combining a planetary reducer and a cycloidal pinwheel reducer. Advantages: high rigidity, high impact resistance, and ultra-high torque capacity. Disadvantages: more complex structure and manufacturing process, larger size, and heavier weight. In terms of application, small joints, such as fingers and arms, that require delicate operations usually use planetary reducers and harmonic reducers. Joints that need heavy load capacity, like upper arms and hips, typically use RV reducers. Now let's talk about the cost of reducers. Take Tesla Optimus as an example. Two hands use 12 planetary reducers at a unit price of 500 yuan. 12 cost 6,000 yuan. For harmonic reducers, 6 in the shoulders, 2 in the elbows, about 14 in total. At a unit price of 3,500 yuan, 14 cost nearly 50,000 yuan. In total, the whole body uses 26 reducers, costing about 50,000 to 60,000 yuan, accounting for 10 to 20% of the total robot cost. For some robots, due to different scenarios and requirements, the cost share of reducers can even be higher than 20%. Of course, there is a reason they are expensive. From materials, design, processing, assembly, testing to production, all require strong technical and manufacturing capabilities. For example, materials are usually alloy steel, which is inherently expensive. Gear design is very complex. Gear processing requires gear shaping, hobbing, and grinding, plus heat treatment to improve hardness and toughness. It is estimated that by 2030, if the shipment of humanoid robots reaches 1 million units, the market size of reducers will be around 10 billion yuan.